forces, 6 Newton, 8 Newton, act eastwards and northwards on a body respectively. Calculate the magnitude of their equilibriums. Something comes to mind. Equilibriums. We need to find the resultant first. Once we get the resultant of the two forces, we have successfully found the equilibriums. I repeat, once you get the resultant of the two forces, you have also successfully found the equilibriums. Let's see how this plays out. But before that, don't forget, give me some thumbs up. Share with your students. Share with your network. Then put your comments in the comment section. Let me know what I'm doing right and what I'm not doing right. Don't forget that. So let's delve into this together. Let's learn together. All right, we have a question here. 2 forces, 2 Newton, 6 Newton, 6 Newton, 8 Newton, acting eastwards and northwards respectively on a body. Calculate the magnitude of their equilibriums. So what do we do? The first question, or the first thing, or the first step to take in solving this kind of question is to analyze it. Eastward, let's come here. This is a body. Yes, but the first force, just noting, is acting, or rather acts eastwards. So let's see, this is east. According to my cardinal bearing, this is my east, this is my north, and this is my south, this is my west. So it moves this way. If this is a body, watch this. This is a body. But there is an amount of force acting on this body, 6 Newton in magnitude, towards east. Can you see it now? Towards east, because this is east. According to my own orientation here, is east at this point, and this is 6 Newton acting towards east. At this point, it acts towards north. Another force acts on it towards what? North, or northwards. And we have from here up. This is 8 Newton. Good. We are asked to calculate the equilibriums, the magnitude. Magnitude means size of the equilibriums. In other words, for us to be able to calculate the equilibriums, we must calculate the resultant of the two forces put together. So we found this, we are right. So what do? We close this. The resultant must be somewhere here. Okay? So this becomes R. Interesting, right? If we have this, what should come to our mind in the first place? Pythagoras theory. We can say this is A, all right? This is B, okay? The first force we represent with capital A. The second force we represent with capital B, of course. The resultant force R. Once we find the resultant force, we have also found the equilibriums, or the equilibrium, so to say. So let's go. Let's go. Is there anything that is confusing? Put it in the comment section. Give me some likes, all right? And then share with a network. Let's delve into this. So what we do is simply we take resultant force R can be found using Pythagoras theory, which is given as A squared plus B squared. Good. So we can now say R stands on its own. By the time we square both sides, we multiply both sides using square roots. Look at it. By the time we multiply both sides using square roots, what happens? I want you to see what happens next. This squared, we take care of square root, and we are left with just R is equals to square root A squared, right, plus B squared. Good. Then we do final substitution because we already know what our values are. A is 8 Newton, B is 6 Newton, respectively. So we come here and then say R is equal to square root open, right? Square root for A squared, we have 6 squared. We have 6 and then we square it plus b. The value for b is 8 Newton. Okay, hold on. For a is 8 Newton. Good, good. That's a mistake, but we are correcting it now. So we have 8. Alright. For b, this one is 6 Newton squared. Good. So we continue that way. R is equal to, let's see what happens next. Is equal to square root, we maintain our square root, 8 squared. 8 squared gives 64. And then 6 squared gives 36. Good. Now we have R is equal to square root open. Again, we have our square root. 64 plus 36 is 100. 100. Of course. What do we have here? What do we have here? The square root of 100. How do we find that? It becomes square root 10 raised to power 2. Good. That's the simplest way to find something like that. What do? Cancel square and cancel square roots. Therefore, R is equal to 10 Newton. Let's go back to the question. This sounds interesting, isn't it? Let's go back to the question. The option A is 2 Newton. Option B is 7 Newton. Option C is 10 Newton. And that corresponds to what we have. Option D is 14 Newton. What does this mean? It means that the correct option is option C. Option C is the correct option, and that's the correct answer to this question. It's been solved. Very simple. So let's recap. Let's recap once again. You have a question. 2 forces of magnitude 6 Newton and 8 Newton. The 6 Newton force act towards east. That's this. The 8 Newton force act towards north. That's that. Good. We need to find the resultant force first. And that is this. By the time we do this, we recall that we can find the resultant using a Pythagoras theory. That is a popular theory everybody knows. And we applied it. We applied it, and this is it. At this point, what we did was to substitute. We substitute for A, force A, we substitute with the value 8 squared. And for B, 6 Newton, that's 6 squared. We simplify further, we have 8 squared is 64, 6 squared is 36. And then goes 64 plus 36, 100, square root of 100. Sometimes we need to simplify further so that we see how things evolve or change with time. Look at it. Then we know that 10 raised to the power 2 will give 100. We do this squared, cancel square root, we are left with just 10 and 10 Newton. If this is the resultant, okay, opposites, because we know that the equilibrant always acts opposites. It is of the same magnitude, but acting in opposite direction to the resultant. So if we have this as resultant, whatever is acting opposite, okay, must have the magnitude of the resultant. Therefore, our conclusion here is that R, since we have found R, we have also is equivalent to finding equivalent E. And equivalent is 10 Newton. Solved. That's our recap now. We still maintain the fact that option C remains the appropriate, most appropriate option. And that solves it. You know what? I am signing up now to prepare for another class.